time for panel discussion. And I've introduced the panel in the beginning with Chris Few from Ofgem, with Kimon Nicolaides from MAS, with Thomas Olsen, Lagoni, Johan Söderblom, EIT, Inno Energy, and Matthias Rohr at PSI. And also our presenters are in this discussion. So we have quite a big panel here, and I've done my best to really nail to get some insights through. You will all just get one or maybe two questions. One question from me, and then let's hope we have some questions from the audience as well, and that we have some time. So let's move into this directly, and I will start with the overall perspective from you, Johan, who have been in this industry for quite some while, and as a thematic leader in this at Inno Energy, the knowledge and innovation community, you see a lot of different practices in this industry. So how would you say, how generally speaking, how important and prioritized is cybersecurity for energy companies of today? I mean, comparing to their overall agendas and comparing over time.
Well, thank you very much for asking. It's been interesting to listen to this introduction with the presenters, and I'll try to give you a little bit of an overview here. And if you look at the energy industry as such, I mean, they are going the same route as all industry. They are realizing that the value of data and actually the accessibility of data today. So that is naturally something that is becoming more and more important in the operations. And I would say that traditionally it's exactly what you've been describing here. It's the OT systems that's been where data has been used in order to control operations. For generation of electricity or heat, or monitoring the grid or whatever. So this is something that is where steps are taken, and that's also where I've seen that you have been looking at the examples here when it comes to the vulnerabilities. But we also see now that there are new uses of data that is coming up, and you have used the term smart grids a lot here, but I mean, there are different ways of looking at that. But what we can see initially here is that there are several new uses of data that's coming from several different sources that's being used for new services. And examples of that is when you look at the new rapid trading of electricity, for example, which is something that has opened up since the deregulation, and it's something that is definitely happening in many different areas, and or with very many different new parties coming in as well. We also see that there are on the retail side, the deregulated side, which I think is good to also have in mind, at least if we look at the electricity side or electricity system. There's a complete unbundling that we are going through in Europe, have been going through, and that also has an impact on the opportunities and the capabilities to handle security threats in the systems. But if we look at the deregulated side, which is the retailers and the generators, from the retailer side, we can see that there are new actors coming in that are entirely reliant on data and providing services to the end users that you haven't seen before, where the retail of electricity is secondary of the services offered. And examples of that is, for example, supporting and controlling and financing PV installations in households. This is something where you have new actors coming in and which are utilizing data in order to make an offer as well as providing services afterwards. Moving over then to the regulated side, which is the network. Essentially, that's a monopoly. That's a natural monopoly, since it's very hard to change over to some other supplier of the network. But that is a completely different issue. If you look at the capability to handle threats in that environment, it is a monopoly, which means that there is a regulator that is controlling how much money you as a DSO, distribution service operator, can charge your customers, since there's no market that will control that. That also means that there's in many markets in Europe, there's a hard pressure on the DSOs to be as lean and mean as possible, which means that they do not really have the excess capacity in many cases to take on new functionalities, at least not at the high speed. It requires quite a lot of preparations or time in order to set up, for example, a functioning security organization in a small organization. And it also becomes more complex because at least in some markets, which Sweden and Germany are examples of, there's a lot of DSOs as well. In Sweden, there's about 150, and I think in Germany, somewhere around 900, which means that they're not very big organizations. So that also has an impact on the way to your opportunity, possibilities to handle security in this. So in that respect, everything that can make this process and integrating this into organization with efficient tools, it's extremely important. But I want to say something about the future as well, because there's, again, it's interesting. You have as a premise here, you have the smart grid, which for me it's a bit smart grid is not one thing, but if we look at what this means for the future, which is coming up very rapidly now and driven by the increased renewables coming into all the systems in Europe, actually, what we will need then is flexibility resources that can balance the grid. And flexibility resources, that is exactly what is opening up the grid for more vulnerability, threats. Yeah. Sorry about that. But a very clear example of that is that you wish to integrate some sort of a local control signal in order to control when electric vehicles are charged or not. Otherwise, you have to invest a huge amount of money in the infrastructure. If you can avoid that by introducing IT systems that are giving control signals or price signals to vehicles, then you have gained a lot. And in some instances, there are ambitions to go even further. And then all of a sudden you have connected your entire household to the grid. And these things will happen quite rapidly in the future, because there's such a huge benefit of doing this instead of buying new transformers or cables and installing a reinforcement of it. So this is opening, I think, for threats, and this is where one future where we actually need more of this understanding of the threat in the grids.
Indeed. So I mean, you touched upon this as well. It also becomes quite a challenge from the regulatory perspective, how to regulate on this. And then I would like to move over to Ofgem as a security regulatory body, and head of cyber R&D, Chris Few. How would you say the regulatory landscape is moving, and what initiatives are ongoing, and what's the direction forward? As much as you can say about it.
All right, thanks, Joakim. So good afternoon, everybody. And so what's changing from a regulatory perspective? Well, first of all, I'll just pick up on the comments that Johan made. We're very aware of that trend towards digitalization and the potential implications for cybersecurity attacks and sort of vulnerabilities. As a bit of background to Ofgem, it's a competent authority within the meaning of the EU directive on the security of network and information systems. And we regulate its application across the downstream gas and electricity sector within the UK. The UK takes the NIS directive very seriously. For example, in its implementation in our regulations, where Ofgem's empowered, as are other competent authorities in the UK, to fine operators of essential services up to nearly 20 million euros if they don't take appropriate and proportionate steps to manage the risks to their essential services. So although the NIS directive itself isn't changing, what is changing within the UK, and I suspect elsewhere, is the amount of attention we can give to the operators of essential services that we regulate. We've now recruited a team of about a dozen or so cybersecurity specialists within Ofgem. We typically have several meetings a week with operators to discuss, review, advise on the cybersecurity of their networks. But we're also scaling up further. We'll be running out a program of inspections with further resources brought in for that purpose. And I must say, although Ofgem is primarily originally set up around market regulation and we're sort of led by economists within the cyber team, we're very appreciative. We've had excellent support, I'd say, from the leadership, from the chairman downwards in Ofgem on stepping up the cyber aspects of Ofgem's regulatory function. Part of our work as a competent authority is clarifying what the NIS regulation means by appropriate and proportionate, as it's a pretty ambiguous term, and it's crucial when there's millions of euros potentially at stake, and the supply of electricity and gas to the whole country. As a starting point, we use a cyber assessment framework, which has been developed by our National Cybersecurity Centre. But in my personal view, I see modelling techniques as being a key way of having more informed and detailed debates about the cybersecurity that our operators have in place. If you've got a detailed model, you can start talking about attack paths, and if the attacker does X, Y, and Z, what's the consequence, what's the impact, and what's the proportionate steps that we might expect the operator to take to mitigate those things. So I see this kind of techniques that we've been discussing here and being developed under Energy Shield has been really interesting. Creates potentially new options for us to regulate in more detail. One of the constraints we sort of have to live under as a regulator, we need to be vendor neutral. So I'm really interested in things that are both open source or open standard. I see the meta attack language as open source at the moment. If it or something like it can be pulled through into an open standard, either a European or ideally an international standard, it would draw in more solutions or applications, much easier for us as a regulator to ask or encourage, insist on operators using it or something like it. So that's, in my view, briefly what's changing. Probably more attention from regulators and looking at stuff in more detail. Back to you, Joakim.
Thanks, thanks, Chris. Nice overview. So moving into implementations, as those are typically many organizations are struggling there. First, over to Kimon Nicolaides, Group Head of Digital Services at MAS. Working with many clients in this area. What's your view on the current state and some key challenges and success enablers in addressing those? I think we have Kimon on phone, right? Kimon, I'm not able to hear you. No.
Oh, are you hearing now?
Yes, perfect.
Oh, fantastic. Joakim, thanks for the question. for any nation, the energy sector will be one of topmost criticality. We've heard earlier around the cases in Ukraine and so on. But in order to function, the energy industry itself is highly dependent on underlying digital services, both its own in-house systems and those of third-party providers such as telcos, internet service providers, and so on. So for these reasons, it can be potentially targeted by, amongst others, some of the most advanced cyber threat actors. To deal with this, you need to really understand your risks and how to mitigate them. Now, this sounds obvious, but is often not fully appreciated. One approach to this is to develop a model of cyber risk as a combination of assets, what you have, threats, who or what could do you harm, and vulnerabilities, that which could be exploited. So just to expand on that briefly, firstly, it's vital to establish an accurate asset inventory of your cyber estate in order to know what it actually is you're trying to protect and to avoid cyber blind spots. Now, this is particularly important for energy and other critical sectors where there are large, complex, potentially global systems, or where cyber estates are simply grown by business acquisition. The next point is that effective threat intelligence is really important, as this helps you understand what threats you're facing and, crucially, your current exposure towards them. Finally, you need a formal approach to assessing your vulnerabilities in order to work out those that really matter amongst the complexity and what you can do about them. Now, note the word formal there, and this is exactly where using a structured method of cyber system modeling, such as those we've heard earlier, comes in. So that's really, I think, in a nutshell, Joakim, kind of my thoughts on that.
Thanks a lot. Also continuing in the implementation space, and Thomas Olsen, you are at the Lagonia Engineering company. I mean, highly skilled in cybersecurity of physical systems. You're currently implementing a pilot that I think Chris mentioned briefly. From your perspective, I mean, what are some common challenges? What can automated threat modeling do in this space?
Yeah, so thank you, first of all. And there's been a really good session. Like, a lot of the stuff that we've been looking at with Chris has sort of come up today, so that's obviously a good thing. So starting around the just a little bit of background. So we've done a model of modeling similar to what's been displayed today on an energy system with Chris, and the focus is around how does this tie into the cyber risk cyber assessment framework that Ofgem has introduced in the UK to govern the NIS regulation over here. So really the key challenges that we've come up against, and we've heard that as well, is the complexity around the operational technology. And actually the asset information is probably one of the biggest challenges. We've got to understand that the energy sector, we heard this earlier, maybe a little bit less mature than some of the other industries, but some of these facilities are being built with a long lifespan in mind, which means that we're now into a change process of understanding what these assets or introducing cybersecurity on top of an asset infrastructure that we haven't potentially mapped out as well as we should have done. So that leads to the first challenge, which is, you know, we need to get all this asset information. So as part of our modeling task, we were working with an energy producer, should I say, and really was trying to understand how do we get this information and how do we get that into a tool like SecuriCAD to really understand all the benefits that it can bring. So that's been done, and I would suggest, as in terms of what the tool can, what an automated threat modeling approach can do in terms of cyber risk, well, exactly as Chris said, it's around enabling active discussion and prioritization. Is certainly one of the key benefits that we got from the end user in our case. So we were allowed to do things like explain to them based on information we've tracked out of their assets, in their infrastructure and their architecture, where are these key challenges they're faced with, and where should they put some emphasis? It's not about going in and doing a blanket approach everywhere. It's about really prioritizing and ranking the risk, or should I say the threat against the model that's been built, so that we're looking at the attack paths as a mechanism of explaining which security controls could be enhanced today, where the quick wins are, and what we can do. So that's been probably one of the most interesting outcomes that the company that we've dealt with has seen. So it is a learning process, and if I'm projecting the future as well, that there is a lot of work that has to be done, and this is part of an ecosystem, should I say. It's not one tool fits all. There's not one silver bullet in this industry. So I do believe that there is certainly some benefits to be extracted here, but there's a lot of work to be done around how this fits together with the NIST regulation in the UK, particularly. But we got to take small steps. We can't do everything at once. Is absolutely the message here, because the industry won't change. It's not a super agile industry. Can't be, because of the 20, 30, 40-year lifespan expectancy of some of these assets. So I think that's probably covers my spiel and what we've done.
Thanks. Thanks a lot. Going into, I mean, the for instance, at PSI, Matthias, you develop and integrate software solutions for utilities, manufacturers, and infrastructure providers. What's your perspective on conducting cyber risk assessments and managing cybersecurity in this industry? And that's Dr. Matthias Rohr at PSI.
Yeah, hi, thank you, Joakim. Yeah, we sell control systems, we install them, and next time in a negotiation, I will cite Eric. He calls that a high value asset. Perfect. Nevertheless, we see the increasing awareness for the risks that we have. But on the other hand, as it was mentioned before, the budget is still a problem. Many of the grid operators are basically paid by the government, by the regulation. And the grid operators are in kind of regulation mechanism where they get money back from for buying a transformer, for buying cables, and so on. For buying cybersecurity services or cybersecurity tools, it's a complete different thing to some extent. It's and I think in many countries there are missing incentives to do more than just what is basically required. We have seen in several countries the issue that the regulation increased the requirements, and this is a really good thing. For instance, intrusion detection systems might become now mandatory for grid operators in Germany, and we have seen like cyber risk assessment. Some kind of cyber risk assessment is now mandatory, I think, for most larger utilities. But on the other hand, if you go and use a kind of more sophisticated thing like text simulation, what we've seen in the presentation, I think this is still something which is not very often done. In the case studies you mentioned, RWE, one of the presentations, it's one of the largest utilities, but the smaller ones, for them it's still a thing to make a consulting project with some kind of a text simulation or something like this. And we need to increase the security efforts. So if we sell control systems, we often have additional options, security options. And if you compare to other industries, aviation, for instance, you always have not only copy redundancy, which you also have for control systems of larger utilities, but you also have design redundancy, like it would be you have a system based on Linux and Windows, or two different types of control systems. And this is obviously more expensive, but it's not, it's far from being standard. I don't know numbers, but my estimation would be that less than 1% of the money which goes in the next years into investments in smart grids goes to cybersecurity. I may be wrong, but I think in other industries, banking and so on, it's much more. And if you look at the risks, what really can happen to a smart grid when tech is successful, then it would be really required to increase the possibilities to invest for operators of critical infrastructures. And one more point I want to make is we think this, Robert made it in point in his presentation, the thing is cooperation is very important to make models like the model which Simon presented. You need these models for some kind of automatic analysis. If we install a system, we have with the customers large projects and draw architectures like this. But in the security assessment, which would be a next step, these models would have to be digitalized again. So there's an additional effort just to draw the architectures, and we are really talking about huge models. We have utility customers with thousands of machines, computers, and tens of thousands of substations that will be intelligent in the future, and hundreds of thousands of photovoltaics and electric vehicles. So the complexity is huge, and we need automated analysis approaches and connect the phases from installation of the systems to continuous security assessment.
Thanks, and that's a very actually a very nice bridge into what I'm going to ask Robert Lagerström. First, I just want to mention with I realized that we have reached the time set up before. We will continue, but I understand if you participants need to drop off. And if you need to drop off, a big thank you to those of you that now need to drop off. But we will continue for another 10 or minutes or so, because I think this is highly interesting, at least. So Robert Lagerström, I mean, from the research you are conducting, also looking at implementations, we are looking at quite some scale here. What insights can you provide to us from the research side?
Well, I think there are two things, and I think as Matthias was talking about just before this question, so the systems are really big, and they're complex. So creating these threat models, etc., for everything in one big chunk, that's really difficult. So as I see it, there are two things you can do. Either you make smaller pieces. You start small, and you show some kind of business value for that smaller part of the architecture, and so you do it well in order to get kind of more resources to show what can be done, etc. And I think we saw that, I'd say 10 years ago or 15 years ago or something, with the emergence of enterprise architecture, basically saying, well, create these big models of your entire enterprise to make well-informed decisions. And the companies we were working with, and in the research we were doing, we saw that all of these enterprise architecture projects failed. They tried to take too big of a chunk in one setting. So when they had done their models, they were out of date, and they didn't know what to use them for, and all these kind of things. So I think what happened was that you have to see it more as a kind of a program, and starting you know, in a corner somewhere, or with the most critical system, or with the most complex one, or start with something where you can find business value, and then build on that, and see it not as a project but as a security program. I think that's key. The other thing I would like to say is that what we're doing in research now, we're also looking in how can we automate the modeling. So how can we withdraw this digital information to create the models automatically, so that we don't have to do it manually, which is then time consuming and error prone. So I think there's a lot of things happening in that direction as well.
So thanks, Robert. To Simon Hacks, presenting the Ethoslang. I think you answered big parts of this in your presentation, but how can Ethoslang enable energy companies to do these assessments at scale?
Yeah, actually we are developing Ethoslang just focusing on DSO because they are in our project, but we are providing the basic assets you are having, for example, in your substation, and then don't need to have any security knowledge anymore. So you just pick the assets you know, so RTU or controller or SIS or whatever you call it, and just link it as you see it from your plans you already have. So maybe there's also a way to do some automatic import that you even don't need to draw it all by yourself. And then as this information is already around, yeah, you can just stick everything together and do the simulations. However, as I said, we are lacking at the moment the full stack due to we don't have partners that have the knowledge to provide. But for example, maybe one short success story of MAL is that recently a student doing his master's thesis wrote me and asked me, okay, I want to do a MAL language for generation, so for power plants. Can you tell me how I use MAL for this? So I think we have a good start with the DSOs and TSOs, but the MAL environments are growing and will help in future all players in the energy domain.
I mean, talking about openness and tailorization, Chris, you mentioned the importance of openness for you. Do you want to elaborate on this? I mean, if you want to.
Well, yes. I mean, clearly we can't. Difficult for us to recommend a commercial product to. It implies an influence there, and it's a lack of impartiality. But something like MAL, which is open source, freely available, that has no issues for us. And a question would be about how many tools are there out there which it's kind of compatible with, or are compatible with MAL. And if we could sort of move that towards an open standard, such that product vendors were influenced into producing output from their tools, asset discovery, network monitoring type tools, which produced models in a format that was sort of recognizable by MAL and other sort of associated tools, then that to me would be a big step forward.
And I mean, Erik, can you provide some perspective from foreseeti view on this?
Yeah, sure. I mean, in general, it is important to us that our solutions are not, magic black boxes that just spits out numbers, and you should follow that and use that as gospel. And that's why we are moving towards using MAL and an open source framework so all of the users understand, I mean, why the results are as they are. And also, of course, that you can make your own changes, because we don't know everything. We try to, but we don't yet. So we are very happy that users can make changes to the specifications themselves, add things and drive the adoption of new domains through our community, for example, and collaboration around these languages. And all of our simulations, the attack logic and everything is based on published research and open sources. So we encourage everybody to look into how it works, and yeah, we want to build confidence in our tool in that way, and we think that's the best way forward as well.
Thanks. To start to wrap up this this panel discussion, any of you that would like to add to this discussion with, for instance, some do's and don'ts, maybe some good and bad examples? I don't know.
Hi, Joakim. Can you hear me?
Yes, yes.
Great. Yeah, so I guess from my perspective, you know, based on experience, there seem to be some quite common themes, and I think we've been touching on various ones of those throughout the discussion here, but just a few in my mind that are perhaps worth capturing in terms of do's and don'ts. You know, certainly for me, do take a 360 view of cyber posture, which accounts for not just technology, but also the people and process aspects. That's really important. I think the other one in my mind, actually, which Robert was really alluding to as well just a moment ago, is don't drown in the complexity of your situation. You know, this is a real risk. When things are complex, you just kind of get lost, or as you say, you build a model which takes forever and is out of date and useless by the time you need it. So, I mean, the answer in my mind there is to take a systematic top-down approach. And, you know, you'll never have all the data. If you don't have all the data, work with what you do have, and particularly think like the threat actor. Stay focused on what really matters, and then look to mitigate those risks. The other one, again, it sounds really obvious, but do ensure that recommended mitigations actually get implemented. I mean, we too often see that important security measures never make it to the operational network, or just take too long to get implemented. And then last but not least, don't forget external dependencies that you rely on, such as out-of-country systems and vitally your supply chain. So, you know, there's many, many more, but I mean, certainly those are a few that I wanted to highlight there, Joakim.
Thanks, Kimon. Thanks. More comments from the panel?
Yeah, I want to add a tiny comment to what Kimon just said. The supply chain will be also a thing which we address in Energy Shield, because one main focus was in certification stuff and so on, risk analysis, just on the utility company that, of course, has a large impact on the system security, like they install software, they manage, they operate it. But if you install something and the supply chain is not clear, then you might have a problem, even if you install it on a very secure parameter. As I said in one of the presentations, if somebody is already in the OT network, and then it's a high risk. And we worked a couple of years in an open source community, and one comment on open source. Open source does not mean automatically more security. So this might be especially for things like Linux, where many, many people look at the source code, but we have been also in projects where not many people look at that code, because it's not very nice. If you find something, then you will not be noticed by many, many people, like if you find something in the Linux. And this will be also a challenge to have this secure supply chain in open source, because you have volunteer software developers and so on. Sometimes you just know the name, and there we have, for instance, background checks for employees. If you implement these things in an open source project, it's also its own challenge. So for some parts, open source is very good for interfaces, for languages, but you also have look closer. There's no simple answer to open source is just more secure or not.
Definitely, I totally agree. And I mean, from the just to make sure from the foreseeti perspective, I mean, we have the proprietary and solutions, but you can look into all the parts and you can build your own based on a standard, hopefully a standard. So, but I do not want to pitch too much for our solutions now. We've already been 17 minutes over time. A huge thank you to everyone in the panel. Huge thank you to everyone presenting, and to everyone attending this webinar. I truly appreciated it, and if I just need to make a plug on that, we are please follow us on LinkedIn if you thought this was interesting, or YouTube channels, of course. So thanks you, big thank you to everyone, and stay safe.